In your exam, Jamb may ask you which one is oxidizing agent and which one is reducing agent. It is very simple. Okay, so what is an oxidation? Basically, oxidation is the process of addition of oxygen to a substance or removal of hydrogen from that substance. It can also be defined as a process of electron loss. A process of electron loss. While reduction is the addition of hydrogen to a substance or the removal of oxygen from that substance. And it can also be defined as the process of electron gain. Now let's look at the various oxidizing and reducing agents we have. Okay, so let's look at oxidation agent. What is an oxidation agent? Basically, oxidation agent is any agent that accepts an electron. It's an electron acceptor, or any agent that oxidation number decreases in the positive direction. Any agent that the oxidation number decreases in the positive direction. While reducing agents are electron donor, or any element that the oxidation number increases in the positive direction. So let's look at examples of oxidizing agents. Oxidizing agent examples include, you have oxygen, you have chlorine, you have concentrated triazonitrate 5 acid, you have concentrated tetraoxosulfate 6 acid, you have acidified potassium tetraoxo manganese 7, you have acidified potassium heptaoxo dichromate 6, and then you have silver salt or any other metal that is lower than silver in the electrochemical series. You also have manganese 4 oxide and hydrogen peroxide. So this is hydrogen peroxide, H2O2. So these are oxidizing agents that we have. Then let's look at reducing agents. Reducing agents, remember they are electron donors. So reducing agents, we have hydrogen, we have carbon 2 oxide, we have sulfur 4 oxide, we have ammonia, we have iron salts, iron 2 salts, we have sodium or any metal higher than sodium in the electrochemical series. They are good reducing agents. Last but not the least is potassium iodide. So these are reducing agents, and why these are oxidizing agents. Please, it's important that you memorize this. Memorize them, because the examiner is going to ask you which one is oxidizing agent, which one is reducing agent. Now let's look at a very popular question examiners usually ask on oxidizing and reducing agents. Okay, so let's see how to identify oxidizing and reducing agents, because in your exam, Jamb may ask you which one is oxidizing agent and which one is reducing agent. It is very simple. Now remember, an oxidizing agent, one thing you have to know is that an oxidizing agent will always give out to reduced. It will always give out and be reduced in the product, while a reducing agent will always collect and increase. Let me retaliate. An oxidizing agent is going to give out and be reduced in the product, while a reducing agent is going to collect and increase in the product. Let's look at this. Now zinc here, any element that is not combined is 0. Zinc here is 0. So copper here is +2. But look at here, zinc here is now +2 and copper is 0. So which one is oxidizing? It means that zinc here is 0, move from 0 to +2. That means it's a reducing agent. And copper here is +2, from +2 to 0. That means it's an oxidizing agent. Okay, so let's look at this one. Copper here is 0. Then you have triazonitrate 5. Then here is +2. You have water and nitrogen 2 oxide there. So what does that tell you? It simply means that copper here moved from 0 to +2, so it is a reducing agent. This one is what? An oxidizing agent. Are we following? Isn't it simple? Okay, so look at this. Now, this one here is +2, and this one here is what? 0. Then here is what? +2. Here is what? 0. Remember, any element that is not combined is 0. So that means that carbon moved from 0 to +2. So what is carbon? Carbon is a reducing agent, and here this one is an oxidizing agent. It is very simple. So let's look at how to test for oxidizing and reducing agents. So how do you test for oxidizing and reducing agents? To test for oxidizing agents, you use a reducing agent to test for oxidizing agents, and to test for a reducing agent, you use oxidizing agents. I hope we are cleared. Okay. Now, to test for oxidizing agents, you are going to use a reducing agent to do that. And here we are using iron 2 chloride. When you use iron 2 chloride on an oxidizing agent, it is going to move from green to brown. The color is going to change from green to brown. Then, when you use hydrogen sulfide on an oxidizing agent, it is going to give you yellow deposit of sulfur. Yellow deposit of sulfur. Yellow deposit of sulfur, because this is going to be precipitating. This is hydrogen sulfide. Sulfur is going to be precipitating since it is insoluble. Okay, then to test for reducing agents, you are going to use oxidizing agent to test for reducing agents. Now, we are going to use acidified potassium tetraoxomanganese 7. You are going to use that to test. You are going to use that to test for reducing agents. You are going to use that to test for reducing agents. And when you test it, it's going to move from purple to colorless. Please note the color changes, because examiners are going to ask you of the color changes. Then acidified potassium heptaoxodichromate 6. When you use this substance on testing for a reducing agent, it is going to move from orange. The color is going to change from orange to green. It is going to change from orange to green. Please memorize all these color changes, because examiner is going to ask you, especially this particular question, they're going to ask you what is the color, and then they will give you example orange to green, green to orange. You'll not be wondering. So learn how to use mnemonics to remember your work. So for this, you can say OG and not GO. OG and not GO. You can say PC here. You can say yellow deposits. Then you can say GB. So you can use those mnemonics to remember when you see the question in the examination hall. All right, we've come to the end of today's class. In our next class, we're going to be learning how to calculate oxidation number and how to balance ionic equation. So please make sure you watch the videos. So quickly go down to the next video now to watch it on how to calculate oxidation number and how to balance ionic equation. If you are yet to subscribe to our channel, please do so now. All right, thank you for watching. Bye.